Okay. Shh. Hello and welcome to the fourth in our series, Introduction to AI for Designers. Today we'll have our third set of tutorials looking at advanced AI. And next week we will be rounding off the series with a really interesting panel discussion that will include Refik Anadol, Patrick Schumacher, Van Nieuwhof, and many others. It's going to be an extraordinary event. Today, though, we'll be looking at advanced AI. I'm delighted to have a really stellar lineup of instructors today. We have Angelica Ponzio, who is, of course, one of our central team in Digital Futures, responsible for the Portuguese language channel. She's a professor at UFRGS in Porto Alegre in Brazil, having studied at Columbia GSSAP for her master's. We're delighted to have George Guida with us. George is an Italian-American who studied at the Architectural Association, first of all, before sort of doing a master's at the Harvard GSD. He worked for Foster and Partners and is currently a part of the Harvard Laboratory for Design and Design Technologies, and also is teaching with Andrew Witt at the GSD. And then finally, we have Daniel Escobar, who is a Colombian American currently working in New York. He studied, in fact, at Georgia Tech, studied computer science. And both George and Daniel have also been very generous contributors to Digital Futures in the past. So the order is going to be, we're going to start off with George Guida, followed by Daniel Escobar, and eventually moving on to Angelica Ponzio, and then we'll have questions at the end. So I'd like to stop sharing and hand over to George. Welcome, George. Great to see you.
Thanks so much, Neil. All right. Well, hello, everyone. Today I'm going to be covering some creative applications of 3D AI and architecture. And this is part of the advanced course. And Dan and I have given a few workshops in the past year. We're excited to be back. So just a brief overview of what I'm going to cover today. The part one is going to be simply what's going on out there within the 3D space. It's really exciting. There's a lot that has been changing, not nearly as advanced as the 2D space, but we'll dive deeper into that. The second part will be slightly more hands-on. Feel free to follow if you want. We're going to take a deeper dive into what's called neural radiance field. So this will be, let's say, a hello world into that space. Thanks for the introduction, Neil. A few more words. I'm currently a research associate at the Harvard Graduate School of Design. I've been involved in several of these emerging AI courses at the GSD, working closely with Jose Luis de Castillo, Andrew Witt, and I'm co-founder of the practice Architag and have worked for Foster for many years. But generally, my research focuses on synthesizing architecture into technology, into more collaborative, more feedback-oriented design solutions, which use machine learning, human-computer interfaces, and some really exciting new immersive mixed reality tools. Over the past few years, I've taught these several AI workshops and conferences, and a few here, focusing on this really interesting question of 3D form generation. So I've always tried to kind of dive deeper into this question of this balance between our agency as designer and this idea of how can we navigate between intuition or traditional design methods with these AI-aided design tools. So it's been really interesting to follow the development of this generative landscape across all these different modalities. So you think of audio, text, code, video, 3D, across what Sequoia is mapping out in this image as consumer enterprise or prosumer markets. So while this wave of image-based diffusion models has already affected, and there's been some interesting discussions in the last tutorials in this series, while it's affected most of the visual arts, this is increasingly a hot topic and a hot discussion, let's say, between us as architects. So will architects really lose their jobs? Can we create AI systems and interfaces to maintain our agency and decision-making role as designers? So I'm a techno-optimist, but I'm also an optimist in this regards. I don't think this will entirely happen. However, what is next within our discipline is really this rise of 3D generative AI in design fields broadly as well. So before diving deeper into 3D, I think it's helpful to compare this space, this emerging space, briefly with some few insights that we can take from image-based processes that are currently happening. So several of you have explored, I imagine, with models such as Midjourney, or now DALL.E 3 came out, or some of the open source models from Stable Diffusion. These have really had such an impact over design fields. For you think of architecture, urban design, furniture, product design, transport, even now entering into UI, UX. So code or text to product is gradually emerging as well. So a few takeaways stand out from where we are now within this image processing space. And the first is really it's clearly this concept of image quality and also semantic accuracy of these output images, which are constantly improving as each new release is put out to the public. So you have, in this case, using open source models, Stable Diffusion, which is actually not far off from the closed source models like DALL.E or Midjourney, which is impressive. And then come this idea of interfaces, which are getting more and more accessible, often at a cost, but they're more and more available as well. So images, in this case, can easily be stretched or pulled through a process of in and out painting, and even animated through text or image inputs. And what's of most interest in the recent times is that increasing control over these images using models such as ControlNet in modifying and manipulating these images, in this case from even a low-res Google Earth image. So while there are many benefits to 3D, so we have high quality, these accessible interfaces, greater control. Okay, we're still entering into this phase of model personalization or model fine tuning, at least democratizing that. And clearly there are issues of copyright, but what about 3D? So let's start from a performance-based side, which is very well underway with companies like Xcool, and you've had several discussions in these talks, or Delve, which give real-time metrics or analytics or of massing options based on site conditions and several different parameters. While this space is on its way, what's most of interest, at least in this talk, is from the generative form generation perspective, which still has, let's say, some way to go and is at a different phase of development from image processing, from the image processing space. So in this case, from an open source perspective, there are already several models that can generate high quality 3D forms from, let's say, text prompts, from a single image, or from few shot images. Often these combine these previous processes. So think of this diffusion-based image processes with new tools which are emerging, such as neural radiance fields, which we are going to cover today. And in the next part with Daniel, he's going to cover what's called Gaussian splats, which is also an emerging space. So here you can see one of the tools we will also, I'll briefly introduce, which is Dream Fusion. Another interesting one is Instruct Nerf to Nerf, which it starts introducing this idea of gaining control even using this Nerf process. So being able to manipulate an existing 3D object or scene through semantics, through a text prompt, and being able to kind of change that in different ways. From a closed source perspective, you might be asking what's currently out there. So two companies that came in mind are Common Sense Machines, so CSM, and Luma AI. They have a feature, it's called Imagine 3D. They use this current state-of-the-art tools, and I'd say they're currently one of the best image to 3D generation tools. While the image you can see is really good for standard objects, let's say you have some quirkiness to them, but let's say this quality deteriorates when that complexity of that prompt, of that semantic specificity in generating a 3D object kind of, you step out of that comfort boundary of, let's say, pre-trained models, or getting some slightly irregular prompts in a way. NVIDIA might become a big player in this space, I would say is likely to, with their recent release of Magic 3D or Angelo, or their current push towards the space with the Omniums. So this issue often of 3D form generation with AI often comes down to an issue of data and representation. So neural language processes and 2D vision models have reached, let's say, this great proficiency on many tasks, primarily escalated by the availability of data sets. And you could also say the same for text processing tools. You think of ChatGPT and the availability of data that there is within the text space. However, for 3D vision tasks, this has not had that same progress. And this is in part due to, let's say, challenges in computational power. You think of training these models, for example, on the top left, you have this voxel representation. To render an object through those voxels, you're thinking of, let's say, a 64 by 64 by 64 cube. The complexity and computational power to generate objects is quite high. So things are starting to shift, and you think of models like multi-view, for example, approaches such as multi-view, or using those diffusion models, which are slowly starting to improve and help actually the number of data sets available as this 3D space and the VR space as well is developing. This availability of high quality 3D data is becoming more prevalent. So in the last Digital Futures workshop, I covered a model which is called Point E, and this resolves this representation issue simply through the use of points. So it uses data sets trained on point clouds, essentially extracting them from rendered images of a 3D model. So these 3D forms can be generated from text inputs. And what's great about it is that it can actually generate images in a few seconds on even a normal GPU. This model has since evolved into models such as Shape E or Shape, and it works really well with, let's say, those conventional objects. So you have the chairs, the airplanes, the cars. Once you start mixing things up, things definitely start getting a little pretty interesting. And it's also been great in the process, in this kind of middle ground of 3D development, to kind of add in our own intuition, our own training of different models, or in this case, using computational tools or Grasshopper to kind of meet that, finish that process, or add our human intuition or human method or traditional methods within this process. Okay, this brings us to neural radiance fields, which is an exciting new field of 3D machine learning, which is going to be the focus of this short demo or tutorial. And just to, I guess, briefly cover what are neural radiance fields. Neural radiance fields are short for NERF, and a NERF is essentially a neural network, which is trained to generate a set of new 3D images or a 3D representation, for example, of an object based on a set of mostly limited 2D objects. So it takes an input image of a scene and interpolates between these images in order to generate a complete scene. So you think of benefits compared to traditional methods. Okay, this was taken quite a while ago and during nighttime, but some benefits include increased level of detail and texture quality. 3D models can be generated with few images, and you can use these can essentially be used for a variety of input types. So it can be useful for CAD applications, medical imaging, or even video game development. think of creation of assets, for example. And point cloud scenes present a new, interesting creative space for what's called phygital experiences. So in all this, it is worth noting that outputs are not always perfect. And we'll see in the next part how Gaussian splats can at time offer some interesting improved results to this process. So the process through its steps mainly involves on the left side, firstly, generating that set of input images. And the next step is optimizing these camera locations through this NeRF process. And then the final is outputting a rendered scene. So we're going to replicate this process today. I'll give you a brief overview of the process and how you can do this in Rhino using Grasshopper. And we will start this process by creating an input geometry. And this could be, you could use the sample, which I'm going to give you the files for, or input your own geometry. We're then going to extract that information through a C. We're essentially going to extract all the camera frames, and then the process continues in the same way as above to optimize and create this NeRF. However, what's interesting is that these input images can also be modified. So we're going to mainly learn how to create a NeRF, and I will leave you to use the many tools out there to think of modifying these images in different ways. So this process is a snippet of an ongoing research which I've been developing with Daniel, Escobar, and Carlos Navarro. And we've been working on this for the past few months now, and we'll be presenting this at the end of the month, this month in Acadia, at the conference. And essentially what we have investigated is the many ways of giving architects and designers greater control and feedback with AI models, from 3D form generation, image manipulation process, NeRF creation, and finally contextualizing within a Unity agent-based virtual environment for architectural simulation. So it kind of covers this end-to-end process from a very segmented and granular way, which is very much in line with how we can give architects or designers that agency within this process. Okay, so let's start. The very first step of this process is creating those cameras. So when you're creating NeRFs, essentially the main input is those input camera locations. And there are two ways of doing this essentially. One is providing what's called a JSON file, which essentially extracts the camera location of each of those frames. The other is a process called ColMap, which is much more computationally intense. So for the purpose of this workshop, I'm gonna sample how you can generate this process. And if you want to click on this link at the top, I don't know if someone in the chat wants to share that to YouTube or whatnot. However, there is a link of a Grasshopper script that we have made publicly open source. So feel free to click on that and access it. Okay, so let me get into Rhino. And just give a small preview of generating that input data set. Okay, so I'm using Rhino 7, and this is kind of a preview of the general script. And on the far left, we have kind of the description of the three processes. One is generating or input your geometry. The second will be creating the right folders and exporting that camera path. And the third one is simply extracting that camera information so that we can then manipulate neural radiance field. Okay, so I have inputted a sample geometry, and I'm going to go on to some settings, which I've already made. So I've essentially made a black scene. What's good about this, and this is kind of like a trial and error process where essentially what we want to manipulate, what we want to represent is simply shown by this. We can kind of isolate that object. So I made a black ground plane, which you can also, let's say, edit. I made it kind of like, we made it as easy as possible to kind of change and manipulate as you want. what you might also see is how these edges are represented. Essentially, that goes through a piping process. And you can see how you can change the color of these as well. What's good, and the similar process applies to any image-to-image process. It's always good to give some sort of texture. While it's really helpful, while it's really useful to use control net models, for example, where you can take canny edges or depth maps, it's still good to kind of give it a slight more, give that input, or let the model diffuse with more input data. Okay, so feel free to try these out with like different colors and inputs. Let's say each match will, let's say, generate some slight variety of outputs. And essentially what we are generating in this process, and you can kind of see a preview of this, is we've created a spiral of camera locations. And here you can kind of see that this point here would be a camera pointing at that model. And we're essentially going to spiral across this curve. You can kind of see a preview of this in the curve. And we can see this is essentially going to be our path. And we're going to take one frame, extract one frame, and let's say per subdivided point, and these are the number of frames. So for now, we can use 100 points. Feel free to try this with more. NERF advises for this to be, let's say, between 100 and say no more than 300 points will be necessary. Okay, so this is the extraction process. We've added a few handy tools. You can change the position of the camera. So there's different camera angle settings. You can move the target location, the radius, depending on the size of your geometry. It might be bigger, it might be smaller. And once you have the camera set up, I have a file on my desktop. So I've made a file, and you can copy and paste your file path. And we need to add a file folder name. I'm going to say 03 NERF Pavilion, for example. We are going to create the folder. We're going to create that JSON, which takes all those camera frames. So you click the button, and you can see it should have made that. It should have made the image folder and the JSON file. So the way you animate and extract frames from Rhino is very simple. If you have a slider, for example, you can right-click and click Animate. From that, essentially what you want to do is select that same file path, images, and export it. So I'm working with the size of 1024 by 1024. This could be slightly smaller, and it really depends on the computational power that you have on your computer. And you can just copy these same settings with a frame count of 100. You can kind of preview that. So we're just going to go ahead and press OK. And you can see each frame is now being extracted in this image folder. And we have those 100 frames. I'm just taking let's say a sample for now. And we're just going to then test this as a neural radiance field. Great. So pretty quick process. I think there are some comments. Okay. And so now we have the geometry, we have the input frames, and what that then leaves us to the next step. So generating a NERF. So you can see on the top right here, what we're going to be using is a really great tool. It's called InstaNGP. You can Google this, or you can just type in InstaNGP. And essentially, this is a great tool you can use locally on your machines, and it helps with NERF generation, very fast time, and the installation process is super simple. It depends. It's super simple for Windows users. For Mac users, it's slightly more challenging. However, if you do have Windows, please do find what graphics card you have, and then all you need to do is download these folders and run this executable file here. So for example, I have an RTX 3080 graphics card, so you can see I'm in the range of this first series. If you don't know how to see what GPU you have available, you could simply click Device Manager, and let me see. You can go on Device Manager, Display Adapters, and you can see the 3080 or whatever graphics card you have, and then decide which one to download. Okay, so just going to close it out of this. I have a shortcut on my desktop. However, what you are looking for is that exe file. Let me just preview it so that you can see. Open file location. So this is the folder you're going to sample, and essentially you're going for that insta-ngp exe file, and the process of generating a nerf, your very first hello world nerf, is essentially going to simply be dragging and dropping this pre-made folder with that JSON file, and I'll give you a quick preview of what that looks like. The JSON file is essentially all those camera input locations and the file path locations, and the transformation matrices per individual image. So InstaNGP has all the information it needs to kind of position each of these frames. You can drag and drop that folder literally into it. The generation process will begin immediately. So you can start seeing immediately that the process is training, and you can see the loss over time. So what we want is essentially for that loss to be continually dropping over time. Once it starts flattening out, clearly there's the model has essentially converged. I think sharing Zoom at the same time is causing my computer to kind of struggle a little bit. Okay, I'm going to run a model that I have already set. It speeds it up. InstaNGP. Number 2. Oh, it seems to be having a problem. Okay, I'm just gonna let this run for a moment. Usually it doesn't take very long. However, I think there might be an issue with sharing on Zoom and everything. However, you should get a preview immediately from this. I'm gonna try once more. If it doesn't work, I'll give you a preview in the slides and let you guys try it yourselves. Okay, desktop. Here we go. That's kind of one of the catches of using AI models on your local PC, that I'd say my computer is not too happy. The models and trainings that I've done on it. Let's see if this one works. Okay, this seems to be working a little better. Let's see if I can replicate. Okay, so for some reason the other two are having an issue, but you can start seeing how the loss is really going down pretty fast. One thing you can immediately do is start cropping that geometry. There's a few interesting things you can do here. Optimize your model. Let's see. To the bottom, you crop both sides. And really feel free to test out the different parameters. There's quite a few right at the top. I won't do it because sometimes it's GPU intensive and it might crash. However, what's interesting about this process is that you can then export your mesh it. Here it's still training, but you can get a preview, for example, of what that mesh would look like. And you can also start using diffusion processes to then edit this geometry. I'm going to clear that mesh. In this case, you can see This is actually an image which I have diffused and changed over time. So the input geometry was not actually looking like this, or would actually had no colors as well. So I'm going to just give you, let's say, a turntable sample of what that looks like, and you can go and debug visualization. And these, what I'm spinning through is essentially 50, 60, 70 frames, each of those frames which we've generated through that output process. So this is your hello world to nerfs. I invite you to try this process. You can also edit those input images with several of the image or diffusion process tools, and do feel free to test it out. So it's kind of giving you greater control within this process to kind of test out each process. Let me end simply giving a small overview of what comes next after this process. And this is kind of a sample of some of the results we were getting in paper, where you go from that input geometry, you're able to diffuse this process through several of the tools available and create a geometry. We then took that geometry, there are some cleaning processes you can do, and then bring those, for example, into Rhino, bring those into Unity, and start adding VFX or different agent-based modeling tools, or different parameters. But feel free to explore and test these out in different ways. The applications are really broad. Okay, so how could we take this one step further? And with this last tool, we'll be ending this intro or this advanced intro workshop into 3D. But there is this great tool. It's an open source collab, which has been developed by 3 Studio. And I'm just going to give you a sample for that, what that looks like. So for those who don't know, GitHub is actually a really great space where open source, many machine learning open source models are archived. And this is an example of one of these open source tools. So 3 Studio is a unified framework. Essentially, you can use several of these tools through either running it locally on your PC or running it on Google Colab. And so you can just get a preview. There's some instructions to how to get these started. You can load Prolific Dreamer, Dream Fusion, which I'll preview very briefly. And these are some of the sample outputs. So in some of these models, you can have text inputs. Other models have text and image inputs. And it's kind of up to you for how you want to chain and create your own workflows. So you can see a few of these different workflows that you can explore. Okay, so I just previewed, I'm not going to run this because it does take a hot minute, but I'll give you a sample of this process. So essentially, for those who haven't used Google Colab before, Google Colab is an open source Jupyter notebook. You can use several different coding languages. Think of it as a Google Doc for coding. What's great is that it offers cloud-based GPUs, so you don't have to actually burn your computers or have high, let's say, intensive GPUs available. So the way you can see what GPU you're using is by I'll do that again, runtime, change runtime type with a model. Using a collab like this, I would advise to use the A100 collab, which we might need for Daniel's part of this workshop. And to do that, you would need, let's say, one of the pro versions of Google Colab. I think it's like $10 or so a month. So we're essentially initializing all these libraries, downloading all these repos from GitHub. And what you need to do is essentially add a token from this platform called Hugging Face. For those who have not used Hugging Face, I would say this is a great resource to get started with machine learning. And it not only provides educational content, it also provides a great space to access open source models, from multimodal models, computer vision, you name it. It's all available, different data sets. But what's also very interesting from, let's say, an introductory perspective is that you can access this thing called spaces. Spaces are essentially people who have hosted open source, let's say a simple web UI built with Gradio, where you can, for example, let's see if I can think of an example. So text to music. You can try to come up or imagine text or text to speech or different, just testing out different models or image-based models, whatever you want, let's say. And just keep in mind, some have runtime errors, but you can, oh, that one was stopped. You can just explore this and try different models, just get that feel of how things work. And oftentimes they do have the files available. So if you want to dive deeper into the code, you can also do that. So this does take a hot moment to load, but I'll give you a quick sample of what these look like. And you can see how we're loading, in this case, we're loading the Dream Fusion model. You have that prompt input, and you can try this and customize it according to whatever project or prompts you want to generate. Then you can export the mesh, you can export the video, and test out different things. Curious to see what you guys come up with. And just to give a sample, these are some of the sample images that the paper Dream Fusion has put out publicly. So this is a type of resolution you could be working with. Thanks so much. I hope that was useful, and I'm looking forward to see some of the results.
Thanks, George. Super clear, super clear. Daniel, let's move on to you. Great to see you again, Daniel. Welcome.
Awesome. Thank you, Neil. All right, share my screen. Okay. All right, cool. So hi, everybody. I'm going to talk a little bit about just kind of like how these 3D generative models work. And I have a little presentation. It's kind of short, but just to give you an overall idea how they work and what is the trend. So 3D generation, and the images that you see here on the right are like some of these generated images using what we're going to use like Gaussian splat. One of the ideas behind it is the way that it represents a 3D object, and you can kind of see it's kind of like these little elongated circles. And what it does is that essentially it optimizes these circles to represent the bottom image on the on here. And I'll talk a little bit more about that in a few. But just to follow back, so the way that 3D representation or 3D reconstruction has been evolving essentially is having getting better quality, and the performance is getting better. And here are kind of like some of the base models that have been done over like the last 3 years now. NERV being like the most famous one, which came out in 2021. Instant NGP, which was the one that George just showed, came out last year. And then the highest quality one, or like the state of the art, is called ZipNerve. And this one came out this year, and this is the highest quality, but it also has the lowest performance due to the neural network size. And then the one that I'm going to be showing is the 3D Gaussian splatter, which is kind of like a trade-off in between performance and accuracy. But at the moment, it's able to perform real-time rendering much better than like a traditional NERV, and it's also easier to train than a traditional NERV. Okay. All right, so this model, Magic 3D, is from NVIDIA. And I want to show this because this one kind of shows how these 3D neural networks are structured. So one of the initial parts of a 3D neural network is like, how do you represent like the 3D object in space? So they use what they call is like a neural radiance field. In this case, the Magic 3D paper uses the instant NGP representation that George showed. So that's the base 3D field that you're going to optimize to be able to build a coarse representation of a 3D object. And then once you take that 3D object and pass it down, you can get a mesh rendering out of it. And one of the key ideas behind this is that instead of training a 3D model or having 3D objects to train this model with, you're going to be using Stable Diffusion or any generative text-to-image model. And that's what's called a 2D prior. So essentially, you're going to tell it to, I guess, a stock gray rabbit holding a pretend carrot, and then that's going to be generated via like a diffusion model, and then that image is going to get projected out into this 3D field, and then the neural network is going to optimize that. And then further on, this model essentially uses another method that's to get a 3D texture mesh out, which is called deep marching tetrahedron. It's similar to a deep marching cubes algorithm, and the way that it does is it kind of creates like a wrap mesh around an object, and then it's able to texturize it, and it has higher quality. But this is the basic architecture of these 3D models. Another interesting work along these lines that doesn't use a neural radiance field, but it is interesting in the sense that it is using Stable Diffusion 2D image prior, so you can do text to image in painting. And still generate like a 3D generative mesh out of it. And the idea behind this is that you're going to start from like an image, and you can see this image here. And then you're going to project this image using traditional depth mapping. And then you're going to take that depth map, reproject it back, and then in-paint the missing regions, and then start to build out the scene based on that. And you can begin to move the cameras around and then fuse all those generated meshes to generate a 3D space. So this is a different approach, but it still uses similar 2D priors. So you're not training like a 3D neural network. You're just kind of taking like a 2D image generator and then using that to recreate the scene and gluing it together as you go. Okay, skip this. Okay, and then another interesting approach to this is that if you're able to have these unique kind of 3D representations, as we approach the binding of multimodal neural networks, where you can have a combination of like visual location, other features such as clip features, audio, or even text segmentation features. You can then begin to have like a 3D map of the world. And then this becomes pretty useful for training, I guess, robot simulation or anything like related to robotics, where you can input a text command and a robot is able to parse the scene using these neural networks with their embedded features, and is able to perform certain actions according to those. So this is kind of like where everything's merging towards to, where you have this multimodal scene, 3D scene representations, and then the ability of robotics to be able to take those as perception modalities and be able to act upon those. Okay. I'll skip this a bit. And then here's is another similar approach where you can take these neural network fields and then apply it to robotics in the sense that you can represent kind of like a scene, like a kitchen scene, and applying some of these features onto those 3D voxels or 3D fields. You can then be able to locate objects in space. And then, for example, here, where it says place the teapot on the stove, the robot can find that teapot, and then it's able to actually act upon it and move it or hold it based on these neural fields. So I think that's pretty interesting approach that is currently emerging in 3D neural fields, and then combining all these modalities. So this is 3D Gaussian splatting. And you can kind of see what it kind of does, right? So it's essentially, it comes from like a a point cloud, and I'll show that in a bit. It comes from a point cloud, and then that point cloud is going to get bent using like a field, and then those point clouds are going to merge into represent a 3D scene. And here you have a comparison between MIPNERV, which is state of the art, and then InstantNGP, which is the one that George shows. And you can kind of like see some of the artifacts that are from these other models, whereas the Gaussian splat achieves this at this high quality at a much faster training pace than these two other models. So this is kind of like the state of the art at the moment. And then more recently, combining Gaussian splatting and then essentially like Dream Fusion, what George just showed, which is the idea of being able to take text to 2D model, so like Stable Diffusion in this case, and to be able to generate a 3D object out of that. And the way that it works, it's kind of like in this diagram here on the right, where you have your text to image diffusion prior, which is your diffusion model. So you're going to feed in a text into it, and then it's going to generate like a fuzzy view, and then it's going to slowly clean it up or refine it until you have a better, more accurate representation. Once that's done, it gets optimized into a mesh representation, and then a texture representation, and then you finally have a 3D object with texture mesh. So this is the newest version of Dream Fusion, but using Gaussian splatting. And then I'll send, I think I sent the notebook out in the chat, so you'll be able to access that one. Okay, cool. So now I'm gonna go to the collab. Okay, so this collab, let me share this one too. Okay, so this collab is to show you how Gaussian splatting works, and all the functions are here. And the idea behind this is that you can take pretty much a prompt, negative prompt, and then you're gonna input a set of cameras. So you can allow it to generate like a random set of cameras. So essentially, if you have an object in the middle, you can have it generate a sphere of cameras around it, pointing all towards the center of the object, or we can use the generated cameras that George created in Rhino. So these are the cameras that George created in Rhino using Grasshopper, and we imported that JSON file. And you can kind of like see where all the cameras are pointing. So they're pointing towards a center. And then we're going to use this to generate a 3D object based on a text. Okay, so the Gaussian splat takes its argument iterations. So we're going to go for 4,000 iterations. Here's the learning rate. So this means 0.0003, and then the final learning rate 0.005, which means that when it starts, the first iteration is going to go from 0.003 to 0.005, and the learning rate is essentially how fast the neural network should be moving to learn. So if you have a higher learning rate, so this one here, it should go faster, but as you get to more fine detail, you should decrease it, so it's able to pick up like the finer detail. One of the things to note here is that as opposed to the InstantNGP, which it starts from like a field, the Gaussian splat starts from a point cloud. And this is the point cloud that it starts from. So this is about 50,000 points. And these 50,000 points are going to get optimized to form an object based on text. So this is what makes this algorithm much more efficient than the neural radiance fields, is that it starts from a point cloud, so you don't have to have a complicated data structure like InstantNGP. which uses a more complicated structure to get it faster rendering. And then once you do that, then you can run the training process, and then you're going to get the loss curve, which means that if the loss curve is decreasing, then that means it is training and it's conversion into an output. And then finally here, this is the final result. And this is how the object is being generated in 3D as the model iterates over and over and checks whether that object is related to the text or not. So essentially what it's doing is starts from like a very coarse scale, and then it slowly builds up as the model learns, and then it begins to fill in the detail later on. And then here, these are like the final cameras that it used. So when we are training, we actually select a random camera at every iteration. The main idea for this is the neural network doesn't overfit. So in every iteration, it's going to pick a different camera from all these cameras. So some of them are not selected and some of them are. So you can see there's some gaps. So these cameras were not selected during the training process. And they can serve as like testing cameras. And then finally, we can get the final point cloud. So this is what that initial sphere of points, of the 50,000 points, turns out to be once the network is done training. And that is your 3D generation. Okay. And then I'll show another model, which is the image to, where is it? Okay, image to 3D. So this model, this is actually from the Dream Gaussian paper. And if you go to this website here, you can read more about the paper, and you can kind of see here how much faster the Gaussian trains as comparison to like a nerve-based model. So that's what makes this model a little bit more efficient and a little bit easier to use. And they also have some examples of their final outputs from image to 3D. And these are all fully texturized meshes. Okay. So using this model here, and I send this in the chat. Okay. So for this notebook, you can essentially go line by line. So you can hit play here. I won't run it now because it might take a little bit of time, but and then you can keep going, and then you're gonna get to this portion here or this cell that says upload image. You're gonna hit play, and then it's gonna pop up a little button here that says choose file, and you can pick your own image. In my case, I selected this image that I generated before, and then that's gonna load it up into this model. Once you have that, you can hit pre-process image. And what this is going to do is going to try to get a mask out of it. So in this case, it selects the boundary of the initial image, and then it takes this as your input for the next generative steps. So we're not inputting any text here. We're just going to like use the image to try to generate like a 3D model out of it. Once it has this maxed image, you can scroll down here, and then it asks you elevation. So estimated elevation angle default to 0, range from 90 degrees to 90. So if you look down an image, you can try a value of -30. So since my image is pretty much straightforward, I would just leave it at 0. And then once you have that, you can just go hit train, and then it's going to go through this process. So the first process is the stage 1, which is just gonna try to take that image and generate a 3D model out of it. The second process, stage 2, is gonna take whatever the output is of that first process, and then it's gonna try to render a texture mesh out of it. So once that's done, it's gonna process that, and then you can hit this cell here that is gonna generate a video, and then you would get this final video as your output. And so this is what the neural network here thinks that my model should look like in 3D. Cool. And then you should be able to download the object. So that should be able to be saved. I don't have it here, but you should be able to download this object. It would be saved on your tabs here. So whenever you run on your folders here, there should be a cell that says so over here, it tells you like where it would be saved. So it says save model to logs/ai.pointclouds.obj, and it would be saved here under your folders. And you'll be able to take this file and download it. And then if I have that model, I'll show you, for example, I don't know, can you see my screen? Yeah. So you can download any mesh object and you can bring it into Blender, and then you can visualize it in Blender, and then do, I guess, whatever you want to do in 3D with it. So it's pretty useful in that case. So this is a pretty useful model, and feel free to try it out and then see what you can come up with. Okay. I think that's all I have for now.
Thanks, Daniel. That was also super clear. Well, let's move straight on to Angelica. My apologies, I forgot to introduce what you're going to talk about, Angelica, but I'll just leave it hand over to you. So welcome, Angelica.
Hi, Neil. Thank you. Thank you for having me here. So as Neil explained, I'm a doctor in architecture from Profile URGS in Brazil. And I also did my Master's of Science Architectural Design at Columbia University. Well, today I'm going to show a little bit of how to use ChatGPT, and more specifically, how to use DALL.E in ChatGPT, and also a little bit of the other apps and models that I've been using just to try things, and also a little bit of animation. So this one was generated, the image was generated in DALL.E 3 in ChatGPT, and the animation was generated by Kyber. So for those who have never tried ChatGPT and even DALL.E at ChatGPT, this is a new feature that came out really recently, and not everybody has it, but it's available for the Plus users or the paid account. So when you link into OpenAI, and you can up here try ChatGPT, and then you're going to sign up, and you can create your account, or you can create with your Google account, an OpenAI account, which is going to open this image. But you can also, if you now try to look at DALL.E 3, it's not ready yet, as it's only available on OpenAI on ChatGPT for the Plus users, because it's going to link you to the DALL.E 2. So they're about to update this, I think, I don't know. But okay, so when you got into the ChatGPT, if you have ChatGPT Plus, you're gonna see, and then you got into your account, and you're gonna see like these 3 dots, and you can open it, because ChatGPT, the free one is just the GPT 3.5, and the Plus gets you into the ChatGPT 4. And once you get into your account, and then you can click on those dots, and you're gonna end up with this this view, and then you can turn on all the things that you want to use, like the plugins. Now they came back with the browser Bing and the advanced data analysis, which it also works with Python inside ChatGPT. And if you allow all these things, you're gonna end up, when you click on GPT-4 here, you're gonna get to use the default model, which is just the GPT-4. Or if you want to use the browser Bing, which is this one, or the advanced data analysis, which is one that works with Python. Or if you want to use the plugins, you have to click this one. Or if you want to use the DALL-E tree, you have to click this. So it's either or. It doesn't work yet with all of them together. So it's this settings. So in settings, you get this screen, and then you go back to this. This is about the plugins. So if you want to turn on the plugins, if you have to click plugins beta, and then you're gonna come up with this window. When you can roll down all the way down, it's gonna got into the plugin store, so you can choose which plugins you want to use. And when you choose the plugins, you're gonna get here on this window all the ones that you choose, but you can only use 3 at a time. So these are the some plugins that I like to use. The web pilot that gets you into internet, and this was before Bing. But the nice thing is that if you mix things, you can use the AI PDF with the web pilot or Canva all together. You can ask ChatGPT to use one of these or all 3 of them. So I got also like Scholar AI, but this is very personal. You're gonna choose whatever it fits you better. And one thing which is really nice, I think you have custom instructions. If you click here, you're gonna open up this window, and then here you can put whatever you want or you don't want to ChatGPT to do. So I'm asking so that he gives me references at the end of the conversations, and I don't want it to tell me that it's a model that doesn't be trained until 2021. And you can write here, and it's going to start doing as a custom definition for you. And you can also write what you want and how you want it to answer, which kind of I put in like an academic professor, so I want this kind of responses that academic or written on an academic way. Well, so now I'm going to show a little bit of the advanced data analysis. You can do a lot of different things, but I was just trying to make a video. So this is just showing that you can see the code that it's working on. And then I gave the ChatGPT with advanced data analysis. You can add here with a plus images as well, or any other files, and it's going to read it. And here I was just simply asking to make a transition between these images to see if they can make a video. I just had to speed it up. I couldn't. Sometimes it does things, but not exactly what you want it to do. So you have to juggle between other models. So I just speed it up on Clidio, but it did the video, so it's just okay. And then this is some images that I generated zooming out on Midjourney, and I'm just showing them here because I was trying with the same DALL-E, with the same code at ChatGPT to see if it could do the zoom out video. And then I got this definition from Min Chao from Twitter, and he just gave it there, just copy paste, and then I put my files here, and it kind of not perfectly did it, but I think it's pretty amazing that just with the input of the images and writing this, the ChatGPT with the code interpreter could do this video. So it's one way to do things. Then finally, the DALL-E 3 beta. So if you want to work specifically with your images. So here I was trying some things that working with my master students about sustainability in architecture, and to see how sustainable the images can get and what information it gives you. And we are trying some things. So it gives you 4 different prompts if you write your prompt, and it's going to generate 4 images with different prompts. You have to specify if you wanted to use exactly your prompt. We are trying about to using a small house, and it always end up having 4-story houses. So, and I was just asking, can you do it with a less number of floors? And you just didn't understand that. The only way it really worked was when I start putting the square meters. So you're gonna see on the next screen. And we are trying to put, it's interesting if you want something different than just a vernacular architecture, it's interesting if you put some concepts. So we are working with sustainable concepts. So we start trying bioarchitecture, bioclimatic, biomorphic, and also location. And as more as you describe what you want, it's gonna give a more accurate image of what you want. So prompt engineering is kind of changing now, because you don't have to put just interrupted phrases with substantives and adjectives, but you can write a whole sentence and you can really talk with it. Oh, okay. So this is just our try here. And here, this is the one that I start trying with different sizes and areas. And I start also asking for a group of houses, and start making too many houses. You're gonna see like here, and then I try to make it understand that I wanted only 4 houses. So we're just making some tests, and then finally get into my 4 houses. So, and I also just trying area view as a metrics. So whenever you put your prompt, it's going to generate these 4 images. And if you click in one of those images, it's going to come with the black screen and all the 4 images there. So you can choose and you can download them. So this is the new interface that they're producing. And here, so this is just a modular house. And then here we start putting the biomorphic thing, and then I start getting some interesting results, more than what we wanted to see. But also something weird stuff, like here you put 4 houses, 2 on top of the other 2. So it's you can also erase this later in Photoshop or even on working on DALL.E. The DALL.E 2 gives you this thing of painting out painting. You can erase it and just put a sky, and it's gonna clear the houses on the top. So concept and styles. What else we have here? Okay. The modeler. Okay. Now with the default model, so it's I just started receiving this last week. On the default model, you can upload images, because before you didn't upload, you couldn't upload images, only on the advanced data analysis. But then it's a little bit tricky to make it describe images from the advanced data analysis, because it doesn't describe exactly the images, but describing the prompt or just guessing what it was. And now what I think is really, really amazing, I put this image that I generated before, and I just wrote describing this image, and it starts describing exactly in very detailed description of everything that was in the image. So we continued with the conversation. Could it be located? Where could it be located? And it really gave me an accurate suggestion of places on the Earth that it could be located. So it's really understanding the images. So it's really useful. So you can, and also we asked, can we consider it a biomorphic architecture? And then said yes. And then we keep on asking about sustainable principles according to DigitalFUTURES, which one author, which we're researching. And then it just give it all the things that the image have, and it has to do with sustainable design. And always at the end of the conversation, because I put the customized with asking to give me some reference, it did give me the reference for the DigitalFUTURES book, and it's really precise. So it's getting better and better, and it's really amazing. Well, about the content policies, they changed a lot of things, and now if you ask, like here, I was just trying to ask something like, give me an image of an interior by Wes Anderson movie, and it just says that you can't do it because it's a copyright image, but you can do something on the style of or resembles it. So this wasn't, this is very precise now. It wasn't doing this before. And then here, there are something that it doesn't understand. Like I was asking for a small house in the Sahara Desert, and I couldn't do it in a lot of different times. I had to just simplify the sentence. So it's tricky. You have to learn how to use it and see what works and what doesn't work. Sometimes the things might not make any sense, but I guess it's just about a trial. And one thing, if you could click here on this board, it will save the whole conversation with a link that you can send to whoever you want, or just copy the text. So you can do this. Well, that what that I showed was ChatGPT on the web, on the browser. And this is the ChatGPT on the app, which is different because now on the app, you can talk with it. And you can also, you can select from new features. I got it for a while, but I mistakenly erased the conversations with the talk conversation, and it just wiped it off my app. And now I just have browser to Bing, but eventually it's gonna come back. And here you can also add pictures, images. I tried the files and the camera, it didn't work for me, not yet, but just the images. And this is just a link so you can have any doubts or questions. They have a lot of useful resources here. So this is a screening of my iPad, where I put one of the images there generated before. And I had this was the prompt that I asked for, and this is the prompt that it changed, and it got things from the previous prompts on the same conversations. Like I didn't invoke that I want a wood, and here says it's a detailed woodwork. But anyway, I was asking again to describe the image and to see how it worked. So this input for images works either in the browser and on the app. So it's just like what is fun here that start saying that this is like organic architecture, just put in the middle, like right, just because it knows that it works with somehow with organic, but doesn't have exactly anything to do with this image. So yes, sometimes things are not 100%. So and now I'm going to show a little bit of Photoshop, which is doing some amazing new features. Photoshop has generative fill and generative expand. So this was the original image that I generated on DALL.E, ChatGPT, and I added this, and I added this woman here. I'm going to show you now here. So this is the Photoshop interface. So you just choose the size of your image, and then you just drag the image, and then you can do the outpainting just by selecting this and then dragging out. And then you can let me see here, you can ask what you want here at the it comes up with this window that's you have to write whatever you want to fill up the void. So I just put a hotel in Brazil, and then it just gives you options. You can generate more options here, and it keeps give you and it doesn't erase the options. Each option is going to be on here, so you can pick it up and then decide which one you want. So you have in different layers, and each layer can, if you want to open the timeline, each layer is going to have a timeline, and you can make a video out of it. So here I'm just putting a woman on the balcony with a binocular, so I just put it here, and I can select the one I wanted. Now I'm going to put the people on a kayak and paddle boards, so it's going to put it there, and it just fits into the scenery. You don't have to do any changes. We can choose sometimes the size and white, and you have to choose what you want to do. I speeded up the video because I use Guida to speed up. So I put some birds, there's some weird stuff, but then I put small birds flying. So you also have to try things to see what works better for you. But then I was satisfied with this flock of birds. And then I was putting another kayak here. Here I'm just zooming in to see that this is the woman with the binoculars. I'm going to put another person on sunbathing, and then you can move these characters because they were infill generated. You can move and you can change. It was going to fit the background. You're going to see now. I put a woman laying on a chair sunbathing, so it's going to couple up with different types of women. Let's see. So here she is, and then I decided to move her. So I have to transform it in an intelligent object. So you see it moves with the background. And then when you click here on the transforming an intelligent object, and then if you remove background, you just have to click it here and then you just fits perfectly there. So this is really amazing. And now just a little bit of Runway, which I think is really fun. And Runway has generation 1 and 2 to make videos. Gen 2, you give an image and then it just, if you don't put any prompt, it's better. So it doesn't change your original images directly, but it's going to just move it and shift it. So it's fun to use it. And you can also on Runway make projects with videos. So this is one project that I made with put sounds, and you just put all your generated images here. And then you can, I'm sorry. And then it just you can add and put all your generated images. But one thing that's really fun is that this series of images, I use another tool here in Runway, which is interpolate. So it kind of shifts from one image to another, interpolating them, which is going to show it here. So this is interpolate is this with the airplane frame interpolation. And then when you add your images on the interpolate panel here, you can add whatever you want. You can put them in order, the order that you want. And you can just click the advance and then decide how long you want it to last and how much does it last also from one image shifting into another. And then you generate, and then it's going to start giving you options here. And you can do the interpolation is going to come up like this, and it's shifting from one image to another. So if you work with a horizontal line as a reference, you can do very interesting stuff. And Runways also always have all these different tools that you can use. Okay, and this is Kyber. I use you can put input images, and then this is the one that I use on the cover. And then I was just testing things here. So it's a different interface and a different result. But I think it's very accurate, it's very precise, the thing that it generates, the definition. Right? I was just playing with my dog just to see, and it's fun to see how it changes. But you can mix things. I don't really use only one thing. And this is something that we working with our students at our university. We were studying this Brazilian artist, Arthur Bulcão, which did all the tiles for they were using Niemeier's work, and we are working with them. And then each group of students pick up a tile composition, and then they start studying, and then later on they work with a grasshopper to do different pavilions. But then I was just taking this style pattern and then I put it on generation 2 and Runway, and start giving me this different. First I put on stable diffusion so in stable diffusion it came up with these people here and the stairs, and I put into Runway generation 2 to animated it. So total 2 was the stable diffusion output, and then I extended on Photoshop, and then I put it on Runway, so I start making different things. So and then I wrote on the prompt that I wanted a building. So it can give you it's really great for to use all these tools on the generative part of when you're just thinking on concepts before you start designing. And this is just fun. I made it, but it has a lot of different models here. So I generated the image on DALL.E. And then I moved it to generation 2 to do the animation. But then I use also Photoshop to extend it, and also to do the infill to put the bird and the balloon, and then on Kyber to change it, and then back to Runway, so I could isolate just the airplane with the dog, and then mix it with the other backgrounds. So you can do a lot of things. Okay. this is it. Just an overview of things that you can do. I just wanted to show the new features of DALL-E at ChatGPT, and a little bit, or you can use as my advice is don't stick on only one model, but the most fun of it if you can start mixing things, which is the greatest. Okay, thank you.
Thanks, Angelica. Amazing. There's so much happening right now, and keeping pace with these things is really difficult. Just in the last week or so, the things that have come out just changed the nature of the game. And I personally have been trying to revise my manuscript for my book on AI, and I initially written my first edition and said, well, we'll be just using voice commands. We won't be typing things. And then, of course, that was when diffusion models came out, and I thought I better change that because we are typing in prompts and things. But now we're discovering we can actually talk to ChatGPT and so on. I'm going back to my original version, but it's literally changing so quickly. And of course, the publishing world cannot keep up with it. And I think also, frankly, the world of education can't keep up with it. And this is why I think these sessions are so vital, in that you really need to have the kind of the most progressive people in the field explaining these things, because it's impossible for any one institution, unless it's possibly MIT, to keep pace with all these things. It is just mind-boggling how quickly these things are changing and so rapidly. So thank you all three. This was really an incredibly helpful session in terms of just trying to track the rate of progress. And certainly since last time when we had our session with George and Daniel, I'm not sure if you were in the same session, Angelica, but the last version, things have moved on so quickly. I've got a couple of questions just to kick things off. Let's say also anyone who's watching, please send some questions into the chat on YouTube, and we can pass them on to our speakers. But my question really is it's kind of connected with the kind of the notion that Randy Deutsch puts forward of the super user. And I'm not quite sure if I interpret it the right way, but I kind of see you guys as kind of super users in the sense of there are two ways of approaching these things. Some of these tools are incredibly accessible to everyone. You don't have to be so advanced at all, and I think Midjourney largely is like that. Anyone can use it without having a deep background in computation. At the same time, there is this notion that we need to have individuals who can look under the hood. You guys and Daniel Bolajan and Wen Yu He and so on. All these people who are able to really to tweak and customize these particular platforms. At the moment, I want to just ask this question: is at the moment it is challenging. I think that the moment you're outlining the best strategy at the moment, and I particularly like the platform that George and Daniel are developing together. But do you foresee that there is going to be sooner or later a highly accessible platform? I got the impression that maybe Runway was getting the closest to that. Maybe I'm wrong, but I got the impression Runway is probably the most approachable. But do you foresee that at any moment in time there's going to be a platform that's just going to make it so straightforward? Or is it always going to be complicated?
Yeah, it's a great question. I think you can already see the big players in the space, Adobe, NVIDIA, are really coming out, even with the Omniverse. They're trying to encompass it all. And it's a matter of time that Midjourney releases its 3D features. So we're really what's interesting is there's two sides of development. One is the big players are developing, but there's also so many different newcomers. So what I'm mainly interested in is how that plays out from an interface perspective. How much feedback, how many of those sliders, how much nuance can we get into without necessarily having to get onto the code level? But it's really interesting. I think there will be all-encompassing platforms for sure, but I wouldn't negate the importance of keeping things open source, permitting even architects to really dive deeper under, and bringing this into schools more and more. So teaching people not only how to use the tool per se, but also understanding, you need an understanding of data sets to have an understanding of ethics, copyright, IP issues, and agency. So I think it's going to be cross spectrum, and it'll be an exciting next few years for sure.
Oh, maybe I could follow that with a question to Daniel. I mean, what makes you stand out, Daniel, is you actually did a master's not in architecture but in computational science, and that reminds me of Shajay, who I'm not quite sure he did a master's. I know he went back to India and did a degree or some instruction in computational science, and he came back much strengthened. And I think that actually that is probably a route that many people should take, because I'm not sure that we can actually accommodate within the world of architecture the kind of knowledge that we really need to bring into the field. But what was your experience of working in a kind of computational science environment as an architect? I've experienced myself of working in, say, the world of critical theory, comparative literature, and I've got to say the standard was really mind-boggling. But what was it like as an architect to be dabbling or to be entering into the lion's den or something, into a world of such ferocious competition in computer science?
So like it was pretty much like relearn like statistics, probability, math. A lot of that stuff, and it's a different way to think about things, I think, than like architecture. I think what makes architecture a little bit interesting is like it's a little bit more fuzzy, versus if you're doing something like an algorithm, because you have to get it to work for it to see a result. So there's no kind of like fuzziness about it. It has to be like pretty black and white. But it definitely is pretty interesting to like think in different terms in that sense. And the reason that I did it was because I was kind of interesting to see how it actually worked. And what is like the mechanism that actually makes something learn. And then when it comes down to it, it's pretty simple. Like the math behind it is rather simple. The hacks and tricks to make these large language models work, or like more complicated models, it comes down to a lot of like engineering. Which that's, you know, how do you make GPUs stack up like and then be able to pass you know, a whole bunch of data into those things. So it comes a lot to engineering. But yeah, it's a fascinating world, and I think like to connect it back to what George was saying, I think like we are starting to see kind of more user interface related stuff as it becomes more popular as well. So I don't know if you need to code a lot. Like I'm starting to use a lot of like ChatGPT to do like a lot of boilerplate code too. So that's kind of cool. And the reason that I like to get under the hood, let's say, of like the code is to be able to like actually do custom things with it that you can't do if it's just like UI, or if it's just kind of like served to you ready to go. And with George and I and Carlos are doing, we're trying to like explore those avenues to see if actually there's maybe some other ways to actually get more control, or how it can be more applicable. But yeah, I think it's definitely worth pursuit for me. It's definitely interesting, and yeah, it's this different field in architecture.
Yeah, no, I know that. I was working in the computer science department in Cambridge years and years ago when I was translating Alberti, and I was surrounded by these amazing geeks. We were perched above the George Babbage lecture theatre. I was just blown away by them. I mean, no social skills, but incredible minds, incredible minds. You think of kind of Stephen Wolfram, those kind of characters. Maybe let's, I just want to repeat, so we're inviting questions from YouTube, the YouTube audience. If you could just send them in and we can relay them now. Maybe Angelica, I could just ask you a question. I mean, one thing was interesting is that you were, you've been teaching this stuff with students. I mean, this is primarily the role, I mean, the area that you've been working in. And I just wanted to maybe get some feedback from you about what your students make of all this. I mean, in some senses, well, I mean, they are the AI generation in some senses. And I'm wondering, how they respond to all this. I mean, there's one question about how the professors respond to all that, so we kind of, in some senses, know that. But how do the students, the ones who are kind of, this is their world, and it is going to be their world when they enter offices or whatever they do in the future. This is going to be the world. How do they? Yeah, well, I just want to hear what their response is.
So sometimes I'm more enthusiastic than they are because they want to see very straightforward things. How can I use this? How can I transform this? Maybe when it gets to 3D, they're going to sense it more. But for the concept generations and I'm actually using this on a design studio. And now that ChatGPT has the DALL.E together, I think gonna do much more things. So we can try different concepts and know how to deal with it. So I'm hopeful that this semester specifically, I can use this on my design class with they are like third-year students, so they can start the design of the project that they have to do. It's a hotel design with already with the keywords that they use. And the other class, which is Grasshopper, we use mostly, they do pavilions, so they use it as inspiration. But some of the designs really use, some didn't, and some did use the AI as a starting point. So it depends, because there's very focused on finishing the semester and using it and using it and know how to use it, so they can really put it on their design. So I think it's a really working process. But the more I'm using it, the more I know how to transmit this to them, and this enthusiasm that I have, and how can they use it, because I can see further that maybe they don't yet. They're very worried about to finish the semester. Now I'm going to start a class at the postgraduate level, mixing interiors, film, and AI. So I'm very hopeful that we can try to make little shorts or films that can be explored theoretically also, because how do you compose the scene? How do you understand how directors use it, and how you can use it to understand the interior theory? So I don't know, let's see. It's going to be like a very short course, and I'm very hopeful next week I'm going to start it, see what comes out of it.
So what you're saying basically is, as long as it's easy and accessible, they're very happy.
Yeah. If it's start getting too much complicated, they really like stereo diffusion so they can control the control net, so they can use a design that they did, or even now when you use platform LookX, and then they start, like last semester, I was really amazed that some of them start finding models that I didn't know. I have different apps because there's so many now, and so they can fit into their own things that they want to. So they start showing me things that I didn't know. So this is very, very, very great and exciting. And I'm really impressed now by Adobe, so Photoshop and the Adobe platform. You can do so many things. Adobe and Runway for me are the two of them are the most interesting ones. And for images, I really like Midjourney for some things. Like for interiors, Midjourney is great. But then now for little designs, little small houses, I think DALL.E is coming to be overwhelming, because the whole thing that you can talk to the AI and you can really explain what you want, and the way it describes the image, that was just like, I was mind-boggling. So how can it describe so exactly what you're seeing, and then you can really talk to it. And then we are researching this sustainable design. We're going to present on Sigrade, just a test that we did. So we want students to generate images that can give them hints how to be sustainable when designing, and it's starting to get good results out of it. So we can do the agency. I'm citing Georgia a lot on our paper with the agency thing. So George and Bolajan. So it's great. It's great that we have all these minds and young minds, and it can share. And it's easy to get it. It's just I start. It's very to do with Runway, or it's just instinctive. You start using, and it depends on how curious you are. The whole thing is about curiosity. So if you're curious, you can manage everything. So.
In a moment, I want to bring Gustavo in to ask his question, but maybe I could just put that same question to you, George. I mean, GSD is a slightly different situation, maybe to Brazil. You've had in the past some like Stan Chilu, some extremely smart master's students at the GSD in terms of computation. How are they responding to these new tools?
Yeah, there's definitely been a recent wave in AI classes, and the demand is definitely there, and there seems to be a strong curiosity in using these tools. But I would also say in sometimes, let's say you give the workshop, and at times then there's a dependence for the tool to give you the answers, or for you not to have that code to write out that code or find this process. Currently, I'm involved with the Master in Design Engineering course, so it's kind of a mix with like the GSD design thinking approach and, let's say, more of an engineering product-based approach. So it's been really helpful for them even to use these tools also from like a data science perspective. Imagine using ChatGPT for data scraping, or like these, or sentiment analysis is really powerful. So I think it's really interesting with the students to see this balance between having to do it the hard way, which is essentially the way we've always been doing things, or manually typing out the code, or doing your research, finding your references, and using these tools to get, an immediate access to them. Harvard has recently made some tools available. There's a Harvard sandbox available. So I think there's definitely momentum, and there's also kind of a reluctance. It's very open. People are very encouraging to use these tools, but I think things are still in the works for to what extent, how are they referenced, or how can they be used?
Maybe just a very brief follow-up question to both you and Angelica. How about your colleagues? I mean, is there a resistance in the design studio from some individuals towards these new tools, or are they on board as well?
In my case, there was, but we have a WhatsApp group. I've been bombarding them with so many things that now they are getting used to it. So yeah, I put all our tutorials and things, and then watch it. And now they're, at the beginning, they were talking about copyrights and worried about how to work with it. But I think as long as people get used to it and start seeing it, it's got more familiar with it. So you don't have to be so afraid or cautious about it. It's just, you have to be careful with certain things. But I guess the more they listen about it, they hear about it, they read about it, the better it is, I think.
And George?
Yeah, you see more and more often being used in the traditional studio context. It's not always described or defended as the AI methodology, but it becomes more of like, this is part of my process. This is how I would otherwise navigate through it. So I think its presence within current studio workflows is definitely revealing itself to be useful. But I wouldn't say there's a strong resistance to it. But a school like the GSD, which is maybe less technical than, for example, MIT, has just so much going on. There's so much critical discourse and so many interesting topics that it is one component in a wider field of areas.
So maybe Daniel, before I bring Gustavo, what about practice? How's it doing in your practice? What is the reception there?
So we've been working pretty much using generative models it's almost like replacing the renderings at this point. And where we can sort of do something really quick and just crank out a whole bunch of the designs instead of going through the process of rendering. We kind of just go off that now at this point. Some of the 3D stuff we've been exploring. I've done some things, for example, with using ChatGPT to write code for 3D structures, which I think that's kind of fascinating that it's able to understand 3D structures. And you can input that to Python code and send it off to Rhino. So I think that's going to be fascinating in a way that if we can interact with 3D structures in that manner and generate the code. And I recently had a conversation with Carlos Bagnon, he's also exploring this type of mode. where he's trying to get it to pretty much spit out G code and have it 3D printed as well. So I think that's fascinating, and that's definitely a pretty interesting avenue that we're going to be seeing. The other stuff that I'm kind of a little bit more interested in now is this idea of like being able to generate simulation environments, and seeing how those can be done generative through these methods that we explore today. And George and I, with Carlos, we have been exploring a little bit of that. And the idea is like, I think Gustavo had a question about this, where the cutting edge of this is kind of being able to blend all these modalities into one model, and to be able to output a variety of features within like the 3D space. And how do you encode that? So I think that's kind of where everything's going. And to be able to have the perception of like 3D environments in that way with all these modalities is very interesting. But I see it more happening in the side of robotics, or at least robotics in that case, they're the ones that are going to benefit the most from text to 3D or any work in like the 3D space. So yeah.
So we got two or three questions in the chat coming in as well. But Gustavo, would you like to make your comments? Yeah.
Hey, good morning, you guys. An amazing session today. So many notes I took in screenshots. You can look in my my Instagram. But I think mostly what I wanted to ask is kind of this kind of art, design, and science edge. I've been working with a lot of chemists, and our group works with quantum biologists and physicists, where they look at their data at the small scale, and they use these high performance computing clusters to come up with data models. And they study all these machine learning archives to validate the papers, like the validity, like what was created and what is missing in the data, like they're data mining, right? So I guess my question here is, how do you see these methods and the role of the architect playing in this intersection between the arts and sciences? Because space, there is a concept of space at the atomic level, at the quantum level, even at the data level, right? Information level. So how do you see these methods really evolving kind of our human perception of space, like the next step? So when we have ChatGPT 8 or 20, you know, what are you looking forward to in the future that you're driving so hard now with this technology?
I'll take a stab at it, but so I think to me, like one of the more interesting things is that we're digitizing like the 3D world like now, like that's completely like available now, and if it's digitized, then a machine learning model can learn from it, and then you can manipulate it, and then you can do all sorts of things with it. So the only thing that I'm kind of like a little bit keen to is the idea of being able to have like pretty much the ultimate perception system at this point. And it's for robotics, and then the idea to be able to like simulate 3D worlds, and then have that apply to train in for robotics or any other thing that needs like a simulation, and then bring that over to the physical. I think that's like common, or at least it seems like that's what people are working on now. How that would affect space, I guess for building or things like that, then it's just a matter of combining all these tools together, and then you can get more efficient buildings, more efficient design. I'm not sure if we're gonna be. I'm guessing at some point we're gonna be able to automate a lot of these things, but I'm not sure like where all this is going. Like it's kind of like. You can kind of see the trend of like blending all the modalities, but yeah, I couldn't tell you like where all this is going at this point.
George, I actually, since you're kind of in the mouth of, you know, technology at MIT and Harvard, there, you know, the powerful, what do you think about the idea of digital twinning and the omniverse? Because we actually had a call here with the head of NVIDIA's Omniverse project. And that's an ambitious vision. How do you see your work intertwining with that vision of intelligent spaces and spaces that can be networked by tens of thousands of people all over the world?
It's a really interesting space, and I think one of the bottom lines is that we're entering into a phase in which there's an increasing fluidity between the digital and physical, which is really exciting. So to build on Daniel's comment, this idea of simulation is super powerful. But maybe just to add to that, I think where our roles as designers can kind of merge this, art design field and the sciences is also from an interface perspective. I think what's interesting with the development of all these tools is how we've started entering into conversation with so many different fields, and what excites me the most, maybe less from a molecular perspective, but it's interfaces that make me, what comes to mind, for example, is what artists like Rafik are focusing more on, or the emerging space of, for example, brain to text. You think of brain to text to image, you think of brain to text to image to 3D, and then add construction documentation, which is coming soon. So I like to throw this curveball and say, soon or one day we'll go to from thought, or a dream, to a fully designed building, which is really provocative. And maybe just to kind of end that thought, I think another way in which it bridges these two spaces, and I'm a big believer in spatial interfaces and how, we need to design those experiences. We need to design how people navigate those multimodal tools. But you think of the medical practice, for example, a doctor diagnosing a cancer patient or using these imaging tools. What's lacking more so than it is in architecture is this idea of trust. And so it applies to a lesser degree within architects, but it will increasingly come. Would you trust an AI tool or an AI model to give you that prediction, 95% chance this image shows you have this malignant tumor, or, bad scenario, possibly. But I think creating that interface between, the professional, the doctor, the architect, or whatnot, with, the patient or the public, I think these type of interfaces and building that trust could be an interesting way of bridging the two spaces.
Yeah, and just to follow up with that, George, I think that the question that I'm alluding to, and I think you answered, is the idea of if we are going to, at some future level, have a 3D real-time picture of the world, and that's going to serve both politicians, robots, and our machines, then what does that do to the human? Because I think that's, ultimately, as architects, I think about human beings first, and then shelter. Or, what do you think about the technology that you're using now, and your students or other researchers? How are they thinking about that when they drive to continually optimizing these tools?
Yeah, there's no holding back. We're on a one-way road, but we're on a one-way road with multiple tangents. I guess I'll answer in the same way. And I think, I'm a techno optimist, so I think using user interfaces, it's how we design these systems, which will kind of be a doom or gloom, or, where we can collaboratively work with these tools. So I think I'm not sure exactly how to answer your question, but I think simulation, I think it's going to be interesting how even the dream space in itself, physical, digital, and subconscious, or, how will these all blend? And but it's definitely an interesting thought.
My final question is for Angelica. Right now, I'm teaching a course on kind of AI and virtual spaces. How do you see the tools? You gave us a wonderful overview. How do you see the role of architects and visual effects and cinema playing in creating your narratives of buildings in 3D space? What are you looking for in these word prompts or prompt engineering to describe space or to look at different forms? Like, what is your overall research question when it comes to form and material instead of using the tools? Like, can you describe that in your process?
You're talking about the theoretical thing of movie, or with using in design studio, or all of them?
Yeah, all of them. Because I think that one of the things that I realize is that students they get overwhelmed, but it seems like because you've practiced for, let's say you're a very experienced practitioner, how do you see these tools that empower you as an architect and doing spatial research?
Yeah,
And then what are your motivations? Like, what inspires you? Is it the landscape? Is it you look at science books? Like, what are the things that help you capture the essence of the space that you love to make?
well, first of all, you can use it for whatever you want, but if you have a purpose, it's much more easier to deal with the models. And in one of our researches, which is with my master student Sara, she's a specialist in sustainability, so I'm kind of channelizing her specialty with dealing with the machine. So I think what is game changer now is that ChatGPT, because before you just input an image and it didn't understand what it was, it just kept like wondering things, but now it really can read it. So it doesn't even it's not only the image reading, but it has access to the whole realm of data, so you can really chat with it and start like talking with almost with an encyclopedia or researcher. So this takes you, I don't know, it's like when you're just imagining things and researching or thinking on all the knowledge that you know, but now it can come up in seconds with an image that reflects that. And this makes you're more creative, because you start looking at it and you can change it, and you can, I don't know, I turn bananas. I'm too enthusiastic about it. And I think if I can pass this enthusiasm to them, it's to them, and so have them imagine what you can do with it, and further down, like taking to possibly to a 3D or even printing it. So it's really I'm very excited about it. So I think it's like you can have an answer back now. Because before you just put some input prompt and then it just give you something, but now you can chat with it. It says, no, I don't like this, I want to change that. And this is like this is the agency that George talks about. You can start like really designing with the machine. And this is the game changer. I think it's just not a tool, a rendering tool, or something that I can use this, or I can go to ArcDaily. No, this is something that you can really interact with. So, and then now if you're gonna start speaking with it, so it's just like, oh my God.
So one follow-up: are you saying that your research is about you talking to machines to make designs, or is your research space blank?
My research is looking for ways to use AI in order to fit it into the design process, to accelerate it, to enhance your creativity, and what does it offers you, and how can you use it into your design process? How can you augment it with the AI?
And that's what a student, when they look at these tools, what they should look at is augmenting their desires or their interests into 3D form, and then take George's, I think, complex process and start thinking about maybe 3D movies or cinema, or, something that they can. I was thinking, why not go to the monuments all over the world, document them, make NERFs of them, make it available as like a contribution to knowledge. But also, if you want to make art, you can just start putting random pictures in front of the NERFs or combining them together and make these new speculative forms or speculative narratives. Like, there's so much territory here. And I just wanted to end to say thank you both. And I think Daniel, who just left, so thank all of you today for presenting. I really appreciate it. And Angelica, as an esteemed colleague, I thank you for all the effort also that you do in our platform. So thanks again.
I just want to say, because I'm following also on Instagram, and there's a question from Instagram from Rachel Girard.
Can we just quickly have the two on the chat first of all that have been there for a while, and we can go to Rachel.
Okay.
There are two questions from Walter Patrick Smith, who is our Education Lab. If you were to ask a genie, what would be some of your favorite AI features to allow? If you had three wishes for a genie, what would be your favorite AI features you would want to ask for? That's the first question. I'll mention the second one second.
Who? I can answer?
Yeah, either of you, both of you. Yeah.
Well, I put on the first slide my favorite ones, but it's Runway and Photoshop. But my really favorite to Genie is that what George and Daniel are trying to do. That please transform this into 3D. But not only now, it's just a beginning. It's just like mesh and it's like the outer shell, but what we really want at the end, I think, is really use it with connecting with BIM, or you can really transform this into documentation. This is I was asking when you about this, how can you mix the generative creative part of the AI with the data analysis and optimization things? So when you are able to join those two, I think we're done. I don't know. So.
Well, we can ask her tomorrow, right?
Yeah.
Okay. What about you, George?
It's an interesting question because there's just so much development happening, and I feel like most of what I would say is probably in development. But my stab at it is, for example, first, more generic. It's keeping systems which have more of that feedback loops and keeping our agents as architects. So kind of embedding that into every future model, I think, is essential. I guess a personal interest could be more from an entertainment perspective. I could see it as like a customizable Netflix model where you could do, for example, your favorite books to a movie and have some sort of customization on that, or imagining a 3D movie in itself to be able to navigate that from different perspectives or different scenes. That's my entertainment space. And the third one is possibly, I guess, building up on my past comment, is finding different ways of building these, brain to 3D form tools. Like how can you lever your subconscious thought in imagining an image, but imagining a 3D shape that you could visualize in Rhino or on a screen? That could be really cool and dangerous at the same time.
Wow. Yeah, no, true. Just one quick question to follow up with you, George, on that. In terms of feedback loops, I mean, I know that, for example, LookX has a kind of generic feedback loop. They're taking on board the preferences that people are making, but I'm not sure whether they're done individually. Do any of these platforms actually have feedback loops whereby it's kind of your platform's being customized and your particular preferences are being built into the model?
Right. I think this brings back to the open source question. So clearly, the more open source the model, the more agency you have in customizing that process. A really great tool today, and Carlos is also in the past. Carlos Bannon is also very much working with, is using the Stable Diffusion Automatic 1111 Web UI. That's a really flexible tool where you have access to the underlying code, all the parameters, and you can start tweaking it according to your workflow. But what's really interesting is how you navigate. I keep describing this process between intuition and the machine. So how, for me, what's always important in an AI project is, the process is also a project in itself and should always be revealed and demonstrated its own right.
I always get the sense with Midjourney, maybe I'm wrong, there is is picking up on preferences in the past, but I'm sure it's not. But that's the way that I perceive it. But certainly if it could be customized towards your particular kind of preferred aesthetic, shall we say, then it would be incredibly useful. You could build upon previous experiences in some way. So there's a second question from Walter Patrick Smith. What are some of the ways you're using to increase students' vocabulary so that they can ask better and describe spaces with greater specificity? Specificity. I can't pronounce it. Sorry.
I think that's what's going to happen now. We have to learn how to describe and how to talk about architecture. And because before, just think of it and then you imagine things and then start drawing and sketching. But now you have to develop another capability, which architects really need to develop. And we can sense this when you started teaching masters. In Brazil, masters are written dissertation. So they have to know how to write and how to read and how to explain in words what you want or what is architecture. So I think this is going to be really great for uniting the theoretical realm with the practice. So we're going to start reading more and explaining more and knowing how to describe. So I guess that's going to be great.
George?
Yeah, I completely agree. This brings the general discussion of like disciplinary knowledge versus non. Let's say, what's the future of our profession? What's the future of education? So when Angelica describes, we need the tools, we need the language to be able to describe with semantic specificity what we want to generate. You need that disciplinary knowledge, and that's kind of like hopefully an excuse to keep teaching architecture in a way. And I think representation, the language also brings up a different topic, which is also representation. I think architecture it's completely multimodal, so it's not just about the semantic specificity, for example, of text, but I also am really encouraging or favorable for like a new digital turn, which has been discussed. But going back to like craft or sketches, we don't just need to know how to describe architecture, but now that we have these control net models or these tools which you can generate images with high fidelity, you can go from a sketch to a high-res image. So when we're talking about creativity, having the language or the tools to be able to sketch or make a simple physical massing model, it could become a new return of craft, which is also interesting to think about.
Okay, and then Richard Gupta, amazing presentation and work, exclamation mark. Yeah, absolutely. Thank you. I'm interested in parametricizing the output 3D generated by AI. Do you think we are heading towards that, or do you have any insights? I'm interested in parametricizing the output 3D generated by AI.
Right, that's a really interesting question, and it brings back to the topic of representation. So we're currently in a moment where most outputs are either point-based, and those points can be often converted into meshes using, common algorithms or marching cube algorithms. The resolution of those outputs is at times limited, and it's kind of a big question in the computer vision space. So what you're asking, Rikta, is from the parametric point of view, I think there is some development. For example, I could imagine dissecting a Grasshopper workflow and using those components as a data set to generate different forms. I think there could be ways of discretizing, of kind of using that input as a data set. I believe there is a interesting data set by Adobe, and they use Fusion 360 elements, which Fusion 360 is essentially made through, processes like extrude, bevel. Every operation is recorded within the final geometry. And so what's interesting is to think of that, for example, there are data sets now, it's slightly old, but think of that as a way of extracting or of generating new outputs. So I'm not sure of current models, but I could see that as a space that could be developed.
I think this matches with the question of Rachel. Is there a way to move from Midjourney, ChatGPT, DALL.E to extract curves and directly start using those curves to create an architecture in Rhino? We have a paper that's going to be presented in Sigradi with Christian Fagundes, which is also, I was co-writing it with his tutored by Lea Bruscato, my colleague, and he's doing this. He's doing curves. He was started using point T, and then he did the other one, I forgot the name. After point E, they have the shape E, and then for shape E, he started. He did the curves, and then he's gonna put it with. He could generate different types of volumes from those curves. So I think it's not that difficult to do it, but it's very interesting if you start doing it and then connecting things, and they can develop a process.
Was that the question from Instagram?
Yeah, she was asking directly for the Digital Futures world. Rachel Jihad, is there a way to move from a journey to extract curves and directly start using those curves to create architecture in Rhino? So yes, there is. We are presenting this, Sigradi. Watch it. But if we're writing in Portuguese, we're gonna start translating into English. Maybe it will be useful.
Well, I'm waiting for the time when AI can translate for us, right? I mean,
oh yeah,
not so far away.
Translators are out of job because you just put everything on the ChatGPT and it translates it perfectly. You ask the tone also, academic tone, and,
Well, I mean, real time in terms of voice is the one that we're looking for.
It's coming. It's coming. It's just.
Coming. I know.
Yeah,
I was at college with a guy called Ted Vick who set up the most successful language translation service in Europe. And he sold last year. He realized the writing was on the wall. I was a translator as well. I spent 3 years translating Alberti, and the fact that it probably could be done. Well, I'm not so sure about Latin actually. Latin's difficult, but I'm always struck by some of those movies, the sci-fi movies that we watched when I was certainly watching when I was younger. Hitchhiker's Guide to the Galaxy, when they had this little thing called the Babel fish, you put it in your ear and you could translate that automatically. So many of those things have come to reality, which is astonishing. Although I have to say that my point about the Hitchhiker's Guide to the Galaxy, where this massive supercomputer called Deep Thought, which is able to give the answer to life, the universe, and everything, which we know is 42 and it caused confusion and so on. That was wrong because it took 10 million years to come up with the answer, whereas ChatGPT could do it in 3 seconds. So the world is changing, and it's almost we haven't got to wait too long before I think we're going to have that immediate translation. I'm going to Tokyo in a few weeks' time, and they're going to be using I think Zoom translation, which is about 60% accurate. But who knows? All of these things are going to improve, and I look forward to the moment when we can actually really communicate properly on a one-to-one basis through language. That will be an amazing breakthrough. So I think we can wrap up now. We've lost Daniel already, but just want to thank George and Angelica. This is such a generous thing you're doing today, sharing your knowledge throughout the world, and it's great when we have followers all over the world following in countries where they're less privileged than the West, and it's great to be able to share that knowledge and to realize that you're breaking down all these barriers to educational ideas, the social, economic, and political barriers. It's wonderful to be able to do that. So thank you for that today, and also the team behind this, because there is a lot of work that goes on, as Angelica and Gustavo and others here know, in terms of setting this series up. I kind of feel that we ought to be thinking in terms of the next series. I think the first series we had 6 months ago, we were already saying, I think we need one in 6 months' time. And I suspect that we're going to probably need another one in 6 months' time, because the world is changing so rapidly. And who knows where we're going to be in 6 months' time. Those predictions about Moore's law are actually been underestimating the speed of change that's happening at this moment. Maybe I could just simply finish off by sharing my screen about a session tomorrow that we're going to be having, which is going to be a kind of complement in some ways to today's session. It's nominally about the dark side of AI. Is there a dark side of AI? And well, who knows? We'll find out in the future, I guess. But what it does in a very significant way is bringing together some of the experts in a particular field. So, for example, we've got Daniel Garcia Espinal, who is from the big Spanish construction giant Ferrovial, who who actually now making roadways, but they were responsible, among other things, for building Gary's Guggenheim Museum in Bilbao. We have Marta Sigari from Foster and Partners, and she's leading the kind of computational side of things in Foster's. Really, a really very informed person. When you heard, who else could we get to be better informed in terms of the development of AI software for the office? But more importantly, also we have Muyiwa, doesn't pronounce his name right, Muyiwa Oki, who is the recently appointed RIBA president, the Royal Institute of British Architects president, the youngest ever appointed and the first ever Black president. I mean, amazing person who campaigned on the basis of being aware of the impact of these digital tools on architecture. And also alongside that, we have Emily Grandstaff Rice, who is the AIA president. So this is going to be a kind of groundbreaking session where we're bringing together people from all these different backgrounds to address this kind of question of what is it going to be like in the office of the future? A question that I guess is impossible to answer just yet, but we're getting some inklings, some indication about the direction in which things are happening. And I think today's session was an incredibly useful contribution to just giving us information about the things that are on the horizon. I mean, so useful. So thank you again. Thank you, George. Thank you, Daniel. Thank you, Angelica. This was really great. I hope we're not out of date too soon, but I look forward literally the next few days to see what's next, because it's incredible how fast this world is moving. So thank you all very much, and see you all the audience tomorrow for a session on the office of the future and how we're going to be using AI. So thank you again, everyone.
Thank you, George. Thank you, Carlos. Thank you, Newt.
Thank you.